Hello everybody. Today we will try to learn to derive a formula for a body moving with mass m at a velocity v. Kinetic energy of this body at time t is equal to half mv square. You all know that. Let us try to derive this formula. That is kinetic energy of a body having mass m with a velocity v at a time t is equal to half mass of the body into velocity of the body at the t time of v square. Let's say it is in joules. The unit of work done or energy is joules. We all know that this formula, very famous formula of mv square. Kinetic energy of body having mass m is with a velocity v at time t is equal to half mv square. Let us derive this formula. Now first of all, think a body at a point rest at a point 1 with initial velocity is equal to 0. Now after t seconds this body is acquired a velocity, final velocity v at point 2. Now let us say the distance traveled in this duration t seconds is s. So according to the work done on this body in moving from point 1 to 2, work done, that is work done for moving this body m having mass m to move from point 1 to 2 is equal to force applied on this body into distance s. In general formula, force into distance is s, force applied in this body. Okay, now what is that is equal to the energy acquired by this mass at point 2 in t seconds, that is half mv square. You have to prove that this is equal to force into distance is equal to half mv square in t seconds. Let us prove this. First of all, force applied is equal to, we all know that mass into acceleration according to Newton's law. Whether it is first law or second law, that is another issue. But force is equal to mass of the body. This mass of the body, this is mass, this is acceleration. But mass into what is acceleration? Acceleration is nothing but the initial velocity minus final velocity minus initial velocity by this time of duration, that is t seconds. You agree with me? Now let us, that is m into v minus t. Let us say this is, let us keep this in bracket, mass into acceleration. Force is equal to mass into acceleration. Now just you are placing the value of force here, then mass into initial velocity minus final velocity by t. This is that, but this is f. I am placing f in place of force. I am placing the value of f, and that this is the distance is as it is. I am keeping. So this is equal to mass into velocity into final it is t as it is. Okay. What is distance? Here distance is average velocity in average velocity. I will write here. Distance or displacement is equal to, this is of course this is a vector quantity. displacement s is equal to, what is displacement s is equal to? Average velocity, or average velocity into time. Now what is average velocity? Final velocity minus initial velocity by this time duration into time t. Okay, average velocity into time is the distance covered. Okay, average velocity into time. So in place of distance I am inserting this value of the s, that is displacement. What is displacement? Final velocity minus in average velocity by average velocity into time t. Okay, now this t cancels, and mass into, what is value of this t cancels, initial final velocity minus initial velocity. What is the initial velocity? Putting the value of initial velocity is always 0. So mass into v by t into, also here also u value is 0 since initial velocity is 0. So u by v. Here v also, here v into v by t. So m into v square by final, average velocity is final velocity minus initial velocity by 2. I am sorry. Okay, this is the average velocity, value of t. Here is t, here is t. Okay. Average velocity, no. Skip mass into this v minus 0 by t into final velocity minus initial velocity is 0 by 2 into time t. Okay, now mass into this t cancels, and v minus 0, v into v is v square divided by 2. This is nothing but half mv square. Okay, force into distance is equal to, that is half mv square, half into mass of the body into final velocity attaining the body at t seconds, v square. This is the work done by the force on this body. It is nothing but, we call that body is having a kinetic energy in joules. Okay, do you agree with me? Work done or kinetic energy of the body. So called, we are calling kinetic energy because of that body is in motion, and the energy of the body having mass m at a velocity v is equal to half into mass of the body and velocity of the t seconds, velocity of the time having velocity v square, v, half into mass into velocity square. Of course we are measuring this energy in joules. Okay, you got it. Thank you all of you. If you understand my theory, yes, like it and subscribe it. Thank you very much. Thank you all of.